Okay. Class 10 students, we are going for the first lecture of this session. Okay. Previously, I was busy making the lectures for the class 11 and 12. So we are not bit late. Okay. We will be managing now in this session. Okay. Because your amount of syllabus is not so huge as class 11 and 12. So preference goes to them. Okay. Yes. We are starting off with the first class of class 10. Now, over here, we see a very beautiful thing. Okay, what is that? We have 3 chapters. First of all, we have current, electricity. Okay, you may get some of the reflections of the line, but I hope so. I will try to avoid. Okay, fine. If you have any sort of reflections in understanding, you can contact me. Okay, we have then magnetic effects, then we have optics. Now, basically this is under CBSE curriculum. This is under CBSE curriculum. Okay, you have to keep in mind this is under CBSE curriculum. But we have something extra for ICSE. We have something extra for ICSE. So what's that extra thing? It's something called work power energy plus laws of motion, plus we have something called modern physics, we have machines, we have heat, calorimetry, everything. Okay. Yes, this will also be covered separately for the ICSE students. Okay, need not to worry. But these 3 chapters are common to both ICSE and CBSE. Now, how should we plan our lecture? We can plan it out in this way. I can move parallelly with current electricity and with optics. Means I can record one class for current electricity, one class for optics. Why I am doing this thing? Last 2 years I am also doing this thing because many schools start off with the current electricity and start off with the optics at the same instant. Okay, different schools follow different pattern. So I am not starting off current electricity, then magnetism, then optics. I will go on with current electricity. Parallelly, I will start off with optics. So it will be, you can correlate with the 2 chapters. And ICSE board people, I will do it in the separate thing. Okay. So let's start off with the very first class of current electricity. Okay. Now, this current electricity is by far you can say one of the most important segment you will be ever studying. Now, those students who are actually preparing for KVPY, NTSC Olympiad, this current electricity, KVPY is held in the month of what? November. So when you will be in class 11, you will be giving KVPY. But when you will be in class 11, so it is hardly you will have any time to go through current electricity. So in class 10, we will be doing current electricity in such a way so that we can actually get up to that level. Okay. So let's start off with current electricity. Now, before we start off with current electricity, let us have some basic knowledge about what is termed as charge. Now this is very interesting. Sir, what is charge? Yeah, you people have done this thing in class 6, 7, 8. Yeah, I've seen. What is charge? Charge is a very special property. Charge is a very special property acquired by some elements. Charge is what? It's a special property acquired by some elements. The special elements. What we say those special elements as? The special elements is termed as electrons. It is termed as protons. Sir, it has many other things. Okay, we are not going to deal with this thing. Okay, fine. Right now, electrons and protons are the basic things. Basic things. Now, where we find all these things? Generally, we find those things in an atom. Generally, we find those things in an atom. Now, electron, it is signified by E minus. Okay. Proton is generally signified as E plus. So many students do confuse. They are exactly the same thing, but opposite in nature. No, it's not the fact. This is a different element. This is a different element. Now this has a charge. Now how this charge is being measured? It is measured by some experiment. Okay. Let's say you can say milk and oil drops experiment. We have all these things to measure the value of the charge. What we get? We get the value of the charge as 1.6 into 10 to the power minus coulomb. Now coulomb is denoted as C. Now many students say, sir, why haven't we put a negative sign over here? Yes. See, we have already stated it is minus. So if I want to talk about the magnitude of the charge, we can say it is 1.6. Yes. To identify the nature, yes sir, this is electron. Then only we will put a minus sign. This minus sign is only put to identify the nature of the charge, whether it is positive or negative. But now else than the charge, we have a mass. Mass of this particle. This mass is 9.1 into 10 to the power minus 31 kg. This is mass of an electron. So mass of an electron comes out to be 9.1 into the minus 31 kg. See, this is very small value. Now let's talk about some protons. Yes sir, we have the charge as similar to that of the electron, coulomb. Now what is the mass of the proton, sir? Is it the same? No, this is not the same. That's why they are different. Okay, it is 1.67 into 10 to the power minus 27 kg. Now check it out. The mass of the proton is very higher than the mass of the electron. But they are having the same magnitude of charge. So what you say? E minus magnitude has the same value of E plus, but mass is different and the proton is having a very higher mass. Next, there are many particles. People will say, sir, I have heard the term beta plus, beta minus, positron, many things. Yeah, there are many things. Let's not discuss these things because we are going for the chapter of current electricity. Why we require the charges? That's why I am telling you the basics. Now another thing we have something called neutral. Now when we say a body to be neutral, a neutral body, simple. Sir, you use the term neutral body. What is meant by this? One word, number of electrons inside the body is equals to the total number of protons in the body. So the word neutral body signifies the total number of electrons inside the body has to be equals to total number of protons inside the body. You should keep in mind, it is the number, not the charge. The number of electrons and the number of protons are equal inside a neutral body. Now, first thing when I'm going to ask the question of many times I ask question to different students ki current is flowing in a wire. Okay, so current is due to the negative charge, so the wire is negatively charged. Many people make this misconception. No, not at all. You can say the wire is negatively charged. The current is due to the flow of the electrons, but the wire is not negatively charged. So what actually it is, we will come to that point. Okay, so right now students, don't write the board. First let me finish the writing of a single board. You first go through it very carefully, give a pause to it, then note it down. Okay, chalo. So this is the first thing we have completed. Okay. Now, let's move on to the next segment. So, sir, starting we have know what is charge, what is positive charge, what is negative charge, what is a neutral body. We have understood all this thing. Now, sir, I will set up something different thing before we go to the current electricity. Yes, from the very basics we know what is current. So, current is something very mysterious thing. You can't see current. No, sir, you can see a flash. You can't see current. You can feel current. You can feel. How you feel it? You feel when you get a jhatka. Okay, when you get a strong resistive force, then you feel the current. So what is actually current? What is current? Current is some sort of, suppose 1,000 of the people are running inside the road. You want to cross the road. So what? Once you get into the road, what you will face? You will face a strong resistive force from the persons which are actually running. Okay. So just try to think of a scenario. Try to think of a scenario. Say from Garyahat. Okay. Let's explain you this thing. Say this is Garyahat. This is Ruby. Okay? All the peoples are aligned in this way. Say in 3 rows, all the peoples are aligned in this way. They are carrying some sort of mashal. You know what is mashal? Okay, yes. This is, and on the upper side, there is a small amount of, you say the moving lantern. Okay? Okay. So, they are all carrying the mashal. Now, all of them starts moving from Garyahat to Ruby. All of them starts moving from Garyahat to Ruby. But in which direction the flame will move? So the flame will move in this direction only. But the flame will be pointed like this way. The flame will be pointed like this way. Okay. Now imagine yourself to be standing on the top of a 10th floor building. Imagine yourself to be at the top of a 10th floor building. What you see? You will see the flares are actually moving like this way. You won't see the flares are moving like this way. You will see the flares are going like this way. But actually the persons were moving in this way. But it seems the flare of the lantern are moving in this way. So what is this? Why have I given you the example? Because actually electrons do move like this way. If the electrons move like this way, you feel a backward effect. It is nothing than a backward effect. This backward effect is termed as current. So we say backward effect. I won't say caused by the motion. Sir, I will better use another term, net. Sir, class 10, because this is class 10, I won't use any further term, because if I use another term, people will get confused. Sir, you are using some high terms. No, I will say net backward effect, because I will let you explain what it happens. Net backward effect caused by the motion of electrons can be sensed as current. Now this is some sort of a basic understanding what can be current. What can be current? Okay. Now, yes, now we will move on to the actual topics. Okay. Now, let us say if I have a region where many positive charges are there, we have another region where we have accumulation of many negative charges. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, 7 positive charges, 7 negative charges. Just think in this way. Okay. Now, we know all the same key, sir. Like charges repel each other. Like charges repel each other, and कि they are all stagnant. They can't move. They are all stagnant. Sir, how they can be stagnant? The charge is on a body. The charge is on a body. Sir, then another question can also occur. Sir, what is a positively charged body? Yes, simple thing. A positively charged body is that body in which the number of protons is greater than the number of electrons, and a negatively charged body is that body where number of electrons is greater than the number of protons. So I use positively charged body. What is a positively charged body? The simple thing, number of proton is greater than the number of electron. And what is a negatively charged body? Where number of electrons is greater than the number of protons. So think in this way, this is a positively charged body and this is a negatively charged body kept at a distance apart. Kept at a distance apart. Now, yes sir, can they attract each other? Yes, they can attract each other, but we have placed them apart by some support. By some support, we have placed them apart. Now, very logically, you tell me. Okay. Now, I will tell you something. This is interesting. Okay. What it says? Ki, this is, assume this is a midline. Sir, for our explanation only, I am using these terms. These are not at all correct terms. For your better explanation, I am using these terms. So don't say, sir, we don't get these terms in books. Okay, why? Yes, because books don't say all these things. This is for your understanding, I am saying. This is, assume this is a midline and this charges equals to this charges in magnitude. Means suppose if it is 10 charges, so there will be also 10 charges. Now, positive charges have some property, negative charges has a different property. What? Sir, positive charge, if I say कि positive charge will create a positive effect on the nearby body, then negative charge will create a negative effect on that body. So we will discuss all these things right now. So before that, you write these points, I will rub off this. Okay? Now, next one. Say this is a positive charge, say Q. Say we express a positive charge, say Q. Now, over here, say this is a point P. This is a distance R. Okay? You can say something like this. The positive charge has created a positive effect. Just like your parents will always provide what? A positive thought process inside you. Okay, suppose you are studying and your parents say, okay, you study well, I will give you a good book for your upcoming session. But once your phone call says and it says, কিরে পড়াশোনা করে কে কত বড় লোক হয়েছে, চল পড়াশোনা বাদ দে, আয় হোয়াটসঅ্যাপে আয়, লকডাউন চলছে পড়ে পড়ে নিবি. So what it will happen? You will just remove your books and start video calling. So what had happened? Your parents has given you some positive thought process. Your friend has given you another thought process. You can say it's negative. So positive effect is being nullified by the negative effect. So this is the same thing. If I place a charge plus Q and at this point P, we can say at point P, positive charge will produce a positive potential. Will produce a positive potential. Now you place a negative charge, say Q dash. Say Q dash. So at point P, negative charge will produce a negative potential. So what is the net potential? So I say net potential at point P. Now what is now few people will ask, sir, what is this potential? Potential is some sort of effect. Potential is some sort of effect. You just think it like this way. Okay, net potential at point P is due to positive plus due to negative. Simple as that. Now I just told you to assume this is a midline. Assume this, thinking this is a midline, and this positive charges is producing a positive effect on this line, and this negative charges is producing a negative effect for this on this line. And assume, I am using the term assume that net potential of this line is equals to 0. Just assume this thing. Sir, why I am assuming this thing? I have just told you, say this is the midline and this is the positive Q and this is the negative Q. That's why. Since they are equal in magnitude and this is the midline, that's why it is happening. If this is greater than this, then the midline won't be at the middle. So then it will be somewhat inclined towards this thing. So for your basic understanding, I am assuming they are equal in magnitude and the net zero potential is the midline between them. Okay? So I hope this is clear. Okay? So once this is clear, we will step on to the next topic. Now, so what we have seen that this is a zero potential line. We are assuming. So we have assumed the midline is zero potential line. Acha, let us name this line as say how you say 0. This is 1, this is 1 dash, this is 2, this is 2 dash. Just name it, okay? I am just naming the lines. This is 1 dash, this is 2 dash. Okay, now very basic thing. If I move towards the positive charges, the distance between the line and the positive charge decreases and the distance between the negative charge and the line increases. So who has the much more greater effect? So similarly we can say 1 dash means line 1 will have greater effect of positive charge than negative charge. I hope so this is clear. Similarly, line 1 dash will have the greater effect of the negative charge than positive charge. Okay, so similarly, now for the line 2. So can we say, sir, V1 means the potential of line 1 is positive and potential of line 1 dash is negative. Perfect. Now sir, we move further to the line 2. So V2 is also positive and V2 dash is also negative. Now can anyone tell me which one is more positive? Line 1 is more positive or line 2 is more positive? Very basic understanding. People will say, sir, line 2 is more positive because it is nearer to the positive charge and far away from the negative charge. So V2 is greater than V1. V2 dash. Now V2 dash negative than V2. No, sir, V2 dash is more negative. See how I write. V2 dash is more negative than V1 dash. Sir, can you give an example? Yes, we will give an example. V0 is 0. Let's say this is a 0 line. Say, now let's take an example. V1, say this is plus 5 volt. Now potential has the unit of volt. V2 has unit 15 volt. So V1 dash, so it comes out to be minus 5 volt. V2 dash is equals to minus 15 volt. Now check this thing, sir. Now check this thing out. We are drawing the same line, okay, with a new name. Okay, so this is 2 dash and this is 2, this is 1, this is 1 dash, this is 2 dash. 0, 5, 15, minus 5, minus 15. Check this thing out. Yes, sir. So, have a clear look at this diagram. As we move from the negative charge to the positive charge, as we move from the negative charge to the positive charge, our potential increases. As we move from the positive charge to the negative charge, the region of potential and the value of the potential goes on decreasing. Yes, this is the most important point I was trying to explain. For this, I have to explain you all this thing. So this is the crunch point I want to say. So first of all, understand this thing very clearly. Give a pause, write this thing, then proceed to the next board. Okay. Now, so what we see, what is the concept plus plus? We use the term concept plus plus because this is the most important concept. The chapter name is current electricity, but whole thing comes out with potential and the potential difference. There is nothing about current. The chapter lies with the concept of the potential. So what is the thing? Concept plus plus. As we move from negative to positive charge, as we move from negative to positive charge, potential increases. As we move from positive to negative charge, potential decreases. Check it out. As we move from positive to negative charge, potential increases. Negative to positive charge, potential increases. As we move from positive to negative charge, potential down. Okay. So over here, now it's a very basic thing. If I place any electron over here, just tell me where it wants to move. Will it move over here? No. A negative charge always repel a negative charge. So it will move over here. Similarly, if I place anywhere a positive charge, it will move over here. So this is the basic understanding which we need to know. Negative charge placed at anywhere will always move from a region of lower potential to a higher potential. So, by nature, this is not I have said, by nature, any negative charge will have the tendencies, or better you say natural tendency. Any negative charge will have the natural tendency to move from a region of lower potential to higher potential. Similarly, any positive charge has the natural tendency to move from higher potential to lower potential. So, any negative charge will have the natural tendency to move from lower potential to higher potential and vice versa. I bet you this thing, you won't find this thing in your books, and this is one of the most important thing you will ever learn in the chapter of current electricity. If you get the concept of potential clear, everything is fine. If you don't get the concept of potential clear, you can't proceed with the simple sum also. So this is the concept of potential. Suppose any positive charge, suppose it is naturally moving without the effect of any external thing. Okay, that means if a positive charge is moving, say from region A to region B, anything, that means you will obviously feel it is moving from a region of higher potential to lower potential. If a negative charge is moving in whatever direction, so that direction is supposed to be a region of lower potential to higher potential. Yes. So this is the basic and the most important fundamental thing which I need to discuss in this first class. So now we will proceed with the next topic. Now, so we move on to the next part of the current electricity. Now, so what we have ultimately has seen, negative charge always move naturally from lower potential to higher potential, and positive charge always move naturally from higher potential to lower potential. Answer, what is the current? We say current to be as the backward effect of the flow of electrons. Current is assumed to be the backward effect of, we say, electron flow. I use the word net backward effect. Yes, I will use this word. While I am using this word, we will come to know. Suppose if one electron, see, basically one electron can't produce a current. Generally we say the streaming of electrons, say they are moving in this way. We generally say the current is flowing in this way. The current is signified by I. Now I use a term net backward effect. Now this is very interesting. This is damn interesting. Okay. What is this? Now, first of all, let us start with the very basic things. Basic things. Where current flow? Current flow in a wire? Yeah. Current flows in a wire? No, flows in a conductor. Current flows in a conductor. What does this conductor have? Conductor has ample of free electrons. Conductor has ample of free electrons. Now, sir, is the conductor positively charged? Now, conductor is itself generally unless stated, the conductor is by nature neutral. Conductor is by nature neutral means number of electrons is equals to the number of protons. These are very, very small questions they do ask in many competitive examinations like NTSC, okay? So conductor is basically neutral. What happens? They have free electrons. Electrons reside in the what? In the outer shells, okay? They get free from the outer shells. Inside they move, they flow. So we have free electrons inside the conductor which actually move. So this free electrons is the cause of current. Now then one of the student will ask, sir, this means any conductor will have current. So why we are touching the conductor? Why can't we feel the current? Why can't we feel the current? So yes, that's the point. So this important thing we will explain with the help of a diagram. Suppose this is a conductor. Okay, they have many free electrons. Suppose E minus, 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 E minus. Now, in random, how they move? They move something like this way. Now, so in general, free electrons move in random motion inside a conductor. Moves in random motion inside a conductor. Random motion is different way. So why we are not getting the current? Now I will explain you the basic definition how current is explained. Many books say current is Q by T. No, this is not the correct definition. Please, no. We have to understand something. Current is defined as net flow of charge. Net flow of charge across any cross-sectional area. Across any cross-sectional area per unit time. This is the way current is measured. Net flow of charge. Net flow. Now, this has some very important thing, but class 10 people we will explain it in an easier format. We will explain it in an easier format. Okay. So what is a cross-sectional area? Cross-sectional area says if you cut the conductor like this way, suppose if you cut the conductor like this way, what you get over here? You get some sort of circular portion, yeah? You get some sort of circular portion. So I draw the circular portion in this way. Okay? Now if I say key number of electrons crossing this cross-sectional area from left to right. So if I say N1 is the number of electrons crossing this cross-sectional area, from left to right. And what is N2? N2 is the number of electrons crossing from right to left. Suppose now we have to check out which is of the greater value. Suppose N1. Say, let's begin with an example. Say N1 is 10 and N2 is 4. N1 N1 is 10 and N2 is 4. So actually, how many electrons has crossed? 6 electrons has crossed from left to right. So I say net movement. Net movement is 6 electrons from left to right. And the 6 electrons are responsible for the current. Sir, in how much time? Yeah, say time taken. Time taken is 0.01 second. Time taken is 0.01 second. Let's take an example. So how we calculate current? Okay, we will show this thing over here. I will rub this thing off. Now, so how to calculate current? This current is due to the net 6 electrons. So what is the charge of the 6 electrons? Sir, I am talking about the magnitude. 1.6 into 10 to the power minus 19 coulomb by 0.01 second. This is coulomb. And total unit comes out to be ampere. So we say 1 ampere is equals to 1 coulomb by 1 second. Okay, so this is the calculation. Why this 6 over here? This 6 is the net flow of charge from left to right, and if the negative charges, flows from left to right, current is directed from right to left. Current is directed from right to left. This is an example. So now we talk about what happens in normal conductor. In normal conductor, without any sort of external connection, means, what do you mean by this term external connection? Means it is not connected with any sort of battery or circuit. If in this case number of electrons crossing from left to right is equals to the number of electrons crossing from right to left per unit time. So this is experimentally proved. So if the total number of electrons crossing from left to right equals the total number of electrons crossing from right to left, what will be the net current? The net current comes out to be 0. So net current in a normal conductor without any sort of external connection at any cross-sectional area is 0. So this is the beautiful logic behind a normal conductor devoid of any sort of connection. Now we will be doing with the conductor with connections. Okay, now when the conductor is connected to a battery, then what happens? Yes, this is very important. Suppose the battery is connected something like this. Now, yeah, we generally say this is what? This is a bigger hand, this is a smaller hand, a bigger plate or a smaller plate. No, sir. Simple. What I use simply, you term this as higher potential. This bigger one has higher potential and this as lower potential. Yeah. See, so this is a wire. Yeah, this is a wire. Yeah. Now, electrons which were over here. Now, electrons will move from where to where? Electrons will move from lower potential to higher potential. So they will try to come to this thing, not this thing. So they will try to come to this thing. So they will all try to move in this way, but they can't move like this way. So what happens? Electrons will try to move towards not positive potential, you say higher potential. Electrons will try to move towards the higher potential. Now in the journey they will be clashing with the atoms. They will move aside, again they move. So they will ultimately move. So this portion is actually in class 12. I am not delving deep into the topic. So simple thing, what we need to know, that the electrons will eventually reach the positive terminal. And yes, electrons will collide with the atoms. See, there are atoms inside the conductor. Electrons will collide with the atoms. They will again move and they will again try to find their way out. So electrons will collide with the atoms and again will find way to the higher potential and again will find way to the higher potential. Yeah, that's the point. So now my question is, what is this collision? Yes sir, this collision. Because of this collision, we will be using the term of resistance. They are facing collision with the atoms, residing atoms. For that only we are having the term called resistance. We will say later on. So till now, electrons after collision, they will reach the positive terminal. So actually, if I name this thing region A and if I name this thing region B, which region is of the higher potential? We will say VA is greater than VB. That's why electron has moved from B to A. That's why electron has moved from B to A. Now, we use a term named as ideal conductor. Ideal conductor, what it happens in ideal conductor, electrons won't face any obstruction. Electrons won't face any sort of obstruction. So that's why we say the resistance is zero. No obstructions, no resistance. This colliding with the atoms, this collision is something we termed as resistance. Means the atoms are resisting the electrons to move in this way, okay? They want to move in this way, but the residing atoms are not allowing it to go in this way. So they are resisting it. So that's why the term resistance came into being. So yes, if the electrons are moving in this way, the current is flowing in this way. So most important point, current flows from higher potential to the lower potential, whereas electron flows from lower potential to the higher potential. So by this thing, let me end the first lecture, because if I go on teaching another thing in the first lecture, you people may confuse. So this is one of the most important class of current electricity. Once you get this thing clear, The other portions are not too difficult. Yeah, we will be doing few tricks to solve the resistance sums. Yeah, that we will be doing in the next class. But this class is conceptually the most important class. No any class you will find more conceptual this one. Any of the classes we will be doing, good classes we will be doing, but no such conceptual classes we will be doing. So this is by far the most conceptual class of current electricity. So, okay students, we will see you in the second lecture. If you have at all any sort of doubts, this is my number. Add me in WhatsApp and send me, call me. I will help you out. Okay? Chalo, so bye bye.